Hey, what's up guys? Welcome back to my channel. Nabit here at HVACroom.com. In this video, I'm going to start the calculations for a sheet metal duct, and we're going to talk about some criteria for medium pressure systems, for low pressure system, and so on. I promise that's going to be so interesting, so let's get into it. Okay, before we start the calculations, we gotta determine that what type of counts we're gonna look at it. For example, we have a static regain method, we have a velocity method, and also constant pressure method. And in this video, I'm going to talk about this one because we do the counts based on this method most of the time. For most systems, in residential stuff, in non-residential, for example, commercial projects, you can go with constant pressure method and you should be good to go. So before I start the calculations, you gotta determine that what type of system do we have. For example, my ductwork is gonna be low pressure system, medium pressure system, or high pressure system. Most of the time, we use the high pressure system for the industrial projects, and I'm not going to talk about that. But for most of residential and commercial projects, if you know how to design the duct system based on low pressure and medium pressure, you should be good to go. In this video, I'm going to talk about low pressure systems. For example, most of the system we have in residential projects are low pressure system. If you are working with constant volume systems like a rooftop unit, like an air handling unit in a small projects, it's like a low pressure system. So as far as the criteria for the low pressure system, we have two factors. The pressure drop should be in this range. For example, 0.08 to 0.1 inch per 100 feet. And also the velocity for this system should be less than 1500 foot per minute. Again, we do have these numbers in a SMACNA standard and also in ASHRAE books. You can double check, but these are the two numbers that we need to go for a low pressure system. So let's do an example here. For example, I have a package rooftop unit or constant volume. Package rooftop unit can be used in commercial project or residential project, and my supply air after the load calculations is going to be around 2000 CFM. We're going to look at the duct size based on these two parameters. So again, as far as the calculations, there are different ways. We can use the graph. This graph comes from SMACNA or ASHRAE. You can find it there. And also this is another ductulator that most of the time, for example, I do the calcs based on this ductulator, and it's very simple and easy. Let me take a screenshot from this guy and work on a 2000 CFM system. So this is the airflow graph. You see CFM here, and this is the friction loss, which we're going to look at it based on 0.1 inch of water gauge per 100 feet. So the simplest method is we can use this arrow here, and from 0.1 I go up, and from this line I can select 2000 CFM. So if you look at it here, this is the intersection, right? So basically, if you look at this point, these are the duct sizes based on round duct. This is 16, this is 20, and my number is between. So let's call it 18-inch diameter. And if you look at this spot, again, between this number and this number, let's call it around 1100 foot per minute, which is perfect. So as far as the duct size, if I want to go with 18 inches diameter duct for a round system, this is what I have. The pressure drop is in the range, the velocity is in the range. So you can determine the sizes easily. Now let's do another example, which is going to be a bigger system. So for example, I have an air handling unit here. This is going to be the duct system. I have some branches here, which is going to serve some diffusers. And I start the CFMs from here. Let's say we have 2000 CFM here, 1600, 1300, and 1100. And these are going to be the discharge. 300 CFM here, 400 here, and 200 here. This is 18-inch diameter duct, and this is going to be 1600. So again, for 1600, if you guys look at it here, let's call it around here. So this is going to be the number, and if you look at it, it's going to be on 16 inches diameter duct. So this is going to be 16. If you repeat the method, it's going to be 16, and the last branch from here, which is going to serve the other zones or spaces, is going to be 14 inch. So again, we're going to look at two parameters. One, friction rate. Second, velocity should be less than 1500. And in the next example, I'm going to talk about how to size the branches for each diffuser. So please let me know what you think in the comments, and please like and share the video with your friends if it was useful for you.